So it is my, oh, there you go, excellent. It is my distinct pleasure to welcome you to ITS. It would have been lovely to welcome you in Athens. Yes, Claude is also waving from there.
Nice to see you, Peter.
Peter is a lot of things, so I'm going to try and read from his Wikipedia page, because he's a professor of information science and intelligence systems and artificial intelligence at University of Pittsburgh. He's very well known for being one of the pioneers of adaptive hypermedia, adaptive web-based adaptive learning. He published a lot of things in these areas. He's also known as being, importantly, #1 in the world in the area of computer education, and also 21st in the world in the area of World Wide Web, as according to Microsoft academic research. He's been awarded Best Paper Awards at all sorts of conferences, him and his group. And he's originally a mathematician. He studied at the famous Moscow State University. Then he's been all over the world, training in Sussex, University of Sussex, Trier in Germany, Carnegie Mellon, and so on and so forth. Amongst other things, I learned that he has coined the explorable explanation for media that uses interactive models to communicate scientific ideas. But today he's going to talk to us about the return of intelligent textbooks, and I'm sure that has connections with various workshops he's organizing. So perhaps then I turn to you, Peter, and tell me what I said wrong. Oh, and I should say, by the way, the Wikipedia page is wrong, because it says you have an H index of 67. Totally wrong. You have an H index of 77.
Okay, well, it's a bad sign when your H index is growing faster than your age. Or maybe it's a good sign. All right, now we kind of a Zoom university, so I'm trying to figuring out how I can share my screen. Oh, no, full screen, large gallery. No, that's not the right one. There should be somewhere in my Teams. I've been using Teams for quite a while. Whenever I talk with Microsoft, they want to use Teams. Okay. So this is share content. It's not probably the right one, no? Oh yeah, this is called share content here.
Share
Excellent.
content is the right one, yes.
Yep. Window. Yep. All right, this one. So you actually should see yourself, guys. For now, you see my slide presentation, right?
Yes, your slides. Yes.
Okay. All right, so really nice to talk about this topic in Intelligent Literacy Conference. As you will see from a few slides ahead, one of the first papers on this intelligent textbooks was in fact presented at one of the ITS. And in general, ITS was remarkable series for me. My first ITS was in '92, and I meet a lot of great people there. And it's I'm so glad to see Claude right here, who has been really the pillar behind the series, and I'm also glad to see so many new people engaged in the organization. So that's nice to see this series thriving, and it's exciting to give a keynote. And it's my second keynote in ITS series, but the first was like 20 years ago. I don't even remember what I was talking about. All right, so today is the topic intelligent textbook, which is kind of one of my topics of interest for the last few years. Oh wait, Alexandra, do I have 15 minutes or it's like a shorter time? Sorry about, didn't check it before.
You have a whole hour, but we should have some time for questions. So yeah, 50 minutes.
Yes, yeah, that's of course, that's understandable. So hopefully I will not bore you guys too much. So intelligent textbook is a really big concern for me right now, and we're working with a number of different collaborators to get a workshop series on intelligent textbooks. The third one is running very soon at AAD, and we also get a special issue of the journal coming on the topic. So I really think it's an important topic, and the issue is it's an old topic, but it's coming back. Just like return of the king or return of the fleets. It's kind of very typical topic in the media. So I also use return of intelligent textbooks. So to get to what I wanted to say, I'd like to show you kind of analogy with the old history. if you look at the Wikipedia page on history, you can see it's divided into ancient history, where there was a lot of nice progress, including classical era like Greece and Rome. And then was kind of, they nicely call it post-classical history. It's also used to be known as dark times or medieval history, where kind of it was a gap between fast progress and people did something, but that was not really exciting. And then modern history, where there is another renaissance of sciences, reading, writing, and everything. So the same thing is happening in intelligent textbooks. That's why I wanted to kind of get analogy with this ancient history, except that it's different years, of course. It's not like the intelligent textbooks appeared in 6,000 years BCE. But it's the analogy. If you like to see that, you can use Wikipedia page. So we start with a kind of even prehistory. We could call it the Stone Age, but it would not be very kind to the smart people who developed that system. We call it prehistory. And that's not about the intelligent textbook. It's about the media on which intelligent books are constructed, which is predominantly hypertext. So hypertext is a separate thing, and it has a very long history, and it has been contributed by a bunch of visionaries. As you can see, Vannevar Bush, you can argue, in fact, that Memex was a kind of the first idea of intelligent textbook, although, of course, it was not. On the other hand, it was the prototype for many different things nowadays. Everyone claimed a part of the fame. Also, Ted Nelson, Andy Van Dam, and Doug Engelbart, who gave the mother of all demos in '68. It was all very much influencing the way we're thinking, and it was, of course, providing very considerable influence on the domain of future research on intelligent textbooks. So that is prehistory. But then, in fact, history starts, and history starts with hypertext finally impacting the way we're doing the textbooks. Textbook has been established through many years. A lot of nice development happening through the years, like page numbers. That was an introduction at some points. We can refer to a page. Index, where you can go to find the concepts and find where it's in a textbook. Glossary, you don't know the term, here's the explanation. So there are a lot of nice developments to establish textbooks as a great learning tool of the past and nowadays. But of course, as long as we get computers, people start thinking how we can get that that medium into the computers, right? And the first idea was, of course, hypertext. Hypertext was really doing more than a normal textbook because it has a structure, it has a link, and people can navigate much better than just like first page to the second page and so forth. So it took a while before this prehistory to the modern history, because the hypertext has to evolve from being just an idea to being kind of practical, right? And I think it happened about 87, so I think that's exactly where this ancient history starts. It's at the same time that HyperCard becomes the first everyday hypertext system, which really impacted lots of people. Also, ICM organized the first conference on hypertext. And incidentally, in the very first conference, a bunch of researchers presented this super book. That was the first thinking of how we can get a new type of books once we're using hypertext. And just like fast forward just a few years, and textbook became kind of the major platform on doing hypertext. There are a bunch of researchers contributed to that. And so here the publication, even more, as long as hypermedia become multimedia, we start getting richer textbooks. So this CLAM, it's online textbooks for teaching modulo 2 by Thomas Boyle, was a very important motivating example for me. For example, that's not intelligent textbook yet. Yet it's a textbook which is built by hypermedia and to some extent multimedia. And of course, people start taking notice. And it was very clear that, well, hypertext is great for your own navigation, but it's not really the one thing for everyone. People have different knowledge, they have different preparation, different goals. And a bunch of researchers in the time, which are kind of analogy of the Bronze Age, start experimenting with the first ways to make textbooks adaptive using the hypermedia platform. Not yet the web, but just the hypermedia. And here are the few projects which I think were kind of all important. Each of them explored different things in making the textbooks adaptive. Again, I kind of try to connect what is happening all over the world with my own work. So here's where I'm started myself. So we built, that time I was still working in Russia, and we built the online textbooks for learning about IC tutor system. It was kind of obscure system to access online information on CD-ROMs. But in the place where I'm working, it was very important that everyone was using that. We get courses to teach it. So we developed this kind of the first way to make a textbook adaptive. And here adaptation has been done using navigation support. We try to use model learners using my experience in intelligent tutoring systems. But this learning model has been used not for do tutoring or sequencing, instead it has been used to do navigation support. We divided pages on ready to be learned, not ready to be learned, and maybe already learned, and we tell the learner which pages are good or not. Pages also included problems and examples, so it was really a bunch of different things. And the first results were quite exciting. We compared the adaptive textbook versus an adaptive version, and in fact, even two different versions on adaptive textbooks, where we have here the things which you're not supposed to be used, you're not ready, which are kind of dark black. And in one version, we decided to remove it. Well, why we should even show it to you? So here is a really interesting summary of main results. So the most important that with navigation support, number of steps and total time used for people to learn the same content has decreased remarkably. But even more remarkable was the decrease of so-called repetitions, where people need to come back to the same type of content because when they came to the first time, it was not just the right time. That's exactly what navigation support tell you. Is it the right time to go there or it's not? So for the normal content, it turns out that for the text content, that it reduced the amount of this wrong navigation when you're not kind of ready for that twice. But even more remarkable is the reduction of time when you try to solve the problem. It's because the system also guides you to the right problems to solve, which are timely for you. If you just randomly go to a problem without adaptation, you have to go to the problem 6 times at average until you really can solve that. If you have navigation support, it's pretty much 1.5 times and you solve it. Sometimes you can solve it, but most of the time you can. That was a very remarkable result, and of course we've been quite inspired. And then what's happening? The classical era came. So the classical era, the kind of the rise of intelligent textbooks. That was the web, right? The web become everyday's hypertext. Well, again, it took a while to pick it up, but much shorter time between the web kind of establishment and the appearance of first intelligent web-based textbooks. Yet in 1996, the first bunch of intelligent textbooks on the web appeared. And again, they created independently by a bunch of different people who has just kind of working on similar things before. And so we developed the kind of reasonably well-known online textbook for learning Lisp, LMART. And Paul Debra in Eindhoven developed, again, well-known adaptive hypermedia course, hypermedia course with adaptive hypermedia. So and there are a bunch of other systems. So the web was, in fact, great push for the working intelligent textbooks. You like to use the web for learning, but the early web has not much but hypertext. There was still no Java, no JavaScript, no Ajax. Most of the time you just can show pages, but you do have some interactivity with CGI scripts, so you can build personalization. And the first personalization naturally came as a personalized hypertext. So that's the example of the LMART. LMART was an interesting combination of intelligent tutoring system for Lisp developed by Gerhard Weber, my postdoctoral mentor at the University of Trier, and our approach to navigation support. We're kind of doing the same thing. We developed textbooks and we provided navigation support to different parts of the textbook using this time not this fancy colored text, but just colored bullets, which could be white, yellow, green, red. And they tell you to what extent a section of textbook is good for you, personally for you, because of your current knowledge. And the provision of Lisp programs, which you can solve and ask the system to diagnose, allowed us to do some really nice student modeling. So we also can provide external navigation support, guiding from that pages to other potential pages, which can give you more ideas or to the glossary. So that was really a very kind of nice progress, and we try to do several different adaptation tools there, powered by true model. So in our case, the model was reasonably simplistic. For every topic of Lisp, we have a separate measure of the learning, and in fact, in one of the later versions of system, we make it open. So here you can see user expected knowledge of different topics, atoms, S-atoms, lists, which is visualization open learning model, but also can be used for navigation support. And here is the system recommendation to what extent it's good for you to use right now, not good. Red means not ready, green, go. Yellow, very likely you know that. So you don't need to go that once again. So here is another case of adaptation, adaptive testing, right? So the set of tests, the set of questions has been given adaptively based on your past history. So we tried a bunch of different things, and Paul Zebra again tried a very different approach in his 2L670 course, mostly focusing on enabling and disabling links, not on navigation support, but using kind of this colored bullets, and also adaptive. Adapting the page contents. So the same page might be looking differently for the users depending on where they're in the course. And every page read was modeled as knowing some of the concept presented on that page. So that is, for example, the same page. Once the user gets through part of that, they already can go to some of the part, and as long as the user learn more, the content is looking differently, more links might be available. So, and that was really exciting for a lot of different people. So we get a lot of very creative ideas, some copycats, just very simple adaptation of existing ideas. For example, our collaborator Marco Specht, was now a professor in Open University of Netherlands, built a really nice system for teaching statistics using the same ideas as we use in MART. But there is a lot of other people who work on that independently and who introduce new ideas. For example, guided tours and individual table of contents in the multi-book project, or open corpus extension of in KBS Hyperbook. Just to show you more examples, so here is the KBS Hyperbook, the project of from Hanover, Wolfgang Nadel and Nicola Henze. So that was to some extent similar to what we did in LMART with different kind of navigation support, but you also can open the at external resources, which was not an option for LMART, and also it has a better student modeling using Bayesian modeling. And just for kind of difference, the other part of the world, that is Slovenia, it's the work on Alice, the work of Alenka Kravčić. Here they try yet another technology, the link recommendation, again based on what you know about Java. Incidentally, as you can see, it was a lot of textbooks on programming, and it's not surprising. To build a textbook, you need to be kind of a computer science faculty. And what computer science faculty are teaching? Well, kind of teaching mostly programming languages. That's why there's a lot of this programming textbooks. So Java, Python, this is also Java, by the way, right? Lisp and others. So that was the first part. I would say it was ancient Greece, right? So the first part of the collecting of ideas. There was a lot of systems, each bring some interesting ideas, and people start talking, thinking, and they try to generalize what they really see. And it turns out that they can distill a bunch of very nice progressive ideas and integrate it all together. And of course, everyone tried to generalize what of that is to move from a special system to teach one topic to kind of an authoring tool, which can support building other type of adaptive textbooks. So on our side, it just like in a year from LMART, we built Interbook. That was the first attempt to do authoring system for adaptive textbooks. So Interbook here used a little bit richer model than LMART. It tried to index every page of learning content with multiple concepts, and it also recognized that the concepts presented on a page might be prerequisites, which we call at that time background knowledge, and outcomes. Prerequisite, which you need to know, and outcome, which you learn on that page. And again, using that rich model, we can do a lot of functionality, for example, this kind of navigation support. So most important for Interbook and a lot of other classical period adaptive textbooks is the idea of knowledge behind the pages. So all of the hyperbooks developed in this time was really knowledge-based hyperspace. So the means that there is a domain model, classic from intelligent tutoring field, set of concepts could be connected by different links, and pages in the textbook has been annotated with this concept. So we know which concepts are presented on the page, and if in some cases what concepts are required to do a page, right? So that is the model, and using the old model, we can do a lot of really nice things. So, for example, this is so-called concept-based navigation. Since we build this rich model behind pages, from a page here, we can go to the landing point, which we call glossary, which explains specific concept. On the other hand, we can also provide links to all pages where this concept is introduced. So if you like to learn more about that, here are the pages, or all pages for which this concept is required. If you learn more about that, now you in fact can go into to try more things. So this is one real value of this knowledge-based hyperspace. And that's another value. For example, you can do content recommendation. If you have a trouble understanding the page because of some missing prerequisites, in fact, you can ask the system for recommendation. And the system can use this concept network structure to assemble a bunch of pages which are helpful for you to learn the missing knowledge. And well, on the top of that, the system also can provide navigation support. So it's a combination for recommendation and navigation support using this kind of prerequisite annotation. So again, it was a very creative set of ideas, and in the second period, like classic Rome, a lot of other authoring tools appeared. So the Paul Zebra's adaptive hypertext course became the AHA, and my mentor Gerhard Weber built another system, NetCoach, with Stefan Weibelzau. Marcus, who moved to a different place, built ACE, and there are a lot of other systems. In fact, existing system has been kind of retooled as the authoring tools, KBase, Hyperbook, and Alice, and the more recent version become the platforms for building more books. And the new system has been introduced from the very beginning as kind of platforms. Since the conference in Athens, it's really nice to celebrate one of the really great early systems of the web-based hypertext is Inspire, developed by Grigardor, Papanikolaou, Kornelakis, and Magos. I don't know if anyone in the audience cheers. It's one of the most influential adaptive hypermedia textbooks by citation, with a lot of really nice features. Okay, so that's kind of the end of the classical period, and it was a lot of nice achievements. We demonstrated that we can build this concept-based, smart hypertext textbooks. And with this infrastructure, you can do a lot of nice things. You can do navigation support, you can do content adaptation, recommendation, you can integrate external content, you can implement rich content, concept-based navigation to interconnect the parts of the book. You can also generate guided tours, and there are some nice ideas how you can construct exercises. It's a lot of great things. And this is just a bit more examples of the systems which has been built at the time. AHA, Metalinks, NetCoach, just to show you more than just our work. So, but at the same time, the classic age came to the end, and to some extent, authoring systems which has been built by a lot of different people, including Alexander. So I'm sorry, I didn't really can't cite everyone because there are so many contributors in the field. But this authoring system to some extent undermined the original success. So, and the main concern, and there are three concerns, I showed them in different fonts, but the main concern was huge knowledge engineering efforts to construct a concept-based textbook. It was a lot of work. It was not really realized once you do your first textbook, because you do it for the domain where you are the expert, your Java course, your hypertext course, your Lisp course. But once you try to move it, now that you have a tool, once you try to move it to a new domain, that turns out to be very hard. When I moved to Carnegie Mellon, I've tried to use Interbook to build adaptive textbook for ACT-R, and it took me a lot of efforts to build the concept models for ACT-R, because the domain experts were not thinking in the same way as we knowledge engineers are. So it turns out to be really very expensive. In that case, the simpler topic-based models, which assume that one page just has one topic behind it, that's it, no multiple concepts, no prerequisites, turns out to be a bit better with practical developers. So Gerhard Weber, who has been using this model in his tool NetCoach, has built a bunch of interesting adaptive textbooks. One of them, unfortunately, in German, to teach you about German wines. So Well, but the second issue was, it turns out when we switch from this the special textbooks, which sometimes have very interesting smart content, like problems on ICE Tutor or LMR problems, we lose something, because the text-only personalization, when you guide to the right page to read, not to the right problem to solve, turns out not to be so important. And it kind of was visible before that, but we haven't realized that. If you go back to this original results of Interbook, the ICE Tutor, this need to go really much back. So you see that there is a value for guiding you to the right page, which is a concept page, to read the right information. You can come to, you need reading, coming to the page not as frequently, but it's only like twice. And it turns out that guiding to the right page is useful, but not very much, because humans are very flexible readers. If a person get to the page they're not ready to read, they still can get something from that. If they're going to the page which is kind of already learned, because all the content conceptually there is learned, they still can get something from that. It's still useful. So it's not really big harm if you're only guiding people to the text pages. What was really the best value of navigation support in the textbook is guiding people to the right problem to solve, examples to try, like to guiding to them to the smart content. And by becoming universal authoring tools, the adaptive hypertext kind of lost that, because if you domain specific, you can get domain specific content. So like, for example, Java problems or Lisp problems here in LMR. So here's a Lisp problems, here are specific Lisp adaptively generated Lisp questions. But when you try to move to tools, you just can get very standard things. So that is, for example, very simple question, fill in the blank question, which we have is Interbook. It was embedded there, but it's really not that fancy, not that rich. But finally, the ways that in textbook has been used to model students were kind of simplistic. So as a result, adaptation was not always precise. Most of the time, if you get to the page assumed to be learned. Well, but it was early days, and we had no idea how to model people from a textbook. So and then we get to this kind of dark age, right? Because the first ideas has been really explored, and it turns out it's very hard to move it to the practice. We know how to build very nice adaptive textbooks, but now you need to do something new, and it's kind of turns out to be very hard. And different teams went through this period of dark ages in different ways. So, but the mainstream work was so-called open corpus adaptive hypermedia, which tried to exclude the work of human expert because it was the main concern. So there are a lot of projects which tried the ideas how to build hyperspace semi-automatically without engaging experts, how we can provide rich linking between pages without concept-based navigation. How we can provide navigation support if we don't have this concept models behind the hyperspace. So well, a bunch of team used social navigation. But most of our work, in fact, was kind of just ignoring textbooks. Okay, well, if you can get main value for guiding you to smart content, not to the text, how about just focusing on smart content? And so for 10 years, we're really mostly focusing on guiding people using navigation support to guide people to smart content and kind of ignoring the textbooks completely. So, but also we tried, and other teams tried to use some kind of automatic content indexing, because content indexing, assigning page to concept, was painful. And it was not that easy to automatically index textbook pages at that time, but it was not that hard to index structured content like programming. So we kind of tried all the things. Let's just quickly show you a few things which we did this time through dark ages, focusing how we can get through. So that is now approach to do to build hyperspace using kind of non-symbolic self-organized maps approach. We get a bunch of textbooks and toss the pages and build self-organized maps to build a kind of knowledge map. And you now can connect to similar pages because they are organized within the same page. That's the system knowledge C. And then we decided on the top of that add navigation support. But because we don't have concept models, we try to use social navigation, which was based on the idea of the social web. So where are the people like you when? Well, it's kind of like collaborative filtering. And so, or maybe even more, where other people like you, in fact, created annotations. That was a project knowledge C2. So this is knowledge CMAP with annotations. The work of other people shown as dark background, and your own work has been shown as color of the figure. So that is the topic where everyone is working kind of reasonably, but you not. The figure is white. And turns out, even without concept models, you can provide some very reasonable navigation support which help people navigate. So it was not completely wrong. And also we built full-blown textbooks with this kind of social navigation support, where we're guiding people to the right pages, not based on the concept models, but based on what other people has been doing. So it turns out, again, it's a great approach. So that's not as working as good as the concept-based navigation, but it's still really working. Well, it's kind of poor man's approach. And that's what we really tried to focus our main part of work, and that's guiding people to the right piece of smart content. And almost 10 years we spent building multiple types of smart learning content, problems, exercises which interactively engage people and provide support. So this is one of our early results. This is adaptive navigation support in a system called Quiz Guide, which guide people to the right problem to solve. Okay, let's fast forward. Let's just get to other interesting ideas. So we also, in fact, try to combine this topic-based modeling and navigation support with social navigation support. And I think that was a very important contribution, because we built a new nice approach, which we called social navigation support. After trying several different ways, we found the best ways to engage students. And the first time it was shown it's really important promise in the progressor. Don't want to talk how progressor works, I'll rather show you how master grids work, which is the system which is working right now. So the idea here is to use the same topic-based model of student knowledge. And in that case, your knowledge is shown by the density of color. This is your knowledge of different topics of, in this case, Java programming, variables, data types, constants. All of these are topics. The darker the color is, the more knowledge you have. But also we can show the knowledge of your peer group. So this is how much your peer group knows, again, density of color. And we can show differential comparison. If it's more green, you're kind of ahead of the group by your knowledge on the topic. If it's blue, then the team, your peer group, which would be whole class or part of the class, is going ahead of you. So it turns out that provides a really great navigation support, guiding people to the right topic, and also remarkably increase their motivation, because seeing how other people work push people to do more. And again, we published a bunch of different things. You also compare yourself with your class on the individual level, as long as the class is not large. 600 students make it kind of very hard to compare yourself. So again, I don't show that, but in master grids, in fact, we have multiple types of smart content. Right now, we have 8 types of smart content for Python. It includes work examples, multiple types of programs, and I think 4 types of content for SQL, and 6 types of content for Java. So that was where our efforts really were mostly spent. Smart content in finding the way to model users with smart content, and finding the way to guide users to the right type of smart content. That's not kind of textbooks. It turns out, however, that was very important. And also important breakthrough for us was to switch from manual indexing to automatic indexing, which was possible in Java. It's not like you have to assign a bunch of concepts to every page, and in this case, to every problem, as we did in LMART, for example. No, by using the code, we can in fact extract concepts. And we did it first for C programming by using specific parser, and then make an open source Java programming parser, which everyone can use as a kind of a service. Give it Java code, which might be a problem to solve or a target code to build, and you get a bunch of concepts. Concepts are taken from the ontology, which a bunch of experts on the topic constructed together. We have ontologies now for Java and Python and SQL. So we also use this combination of topics and concepts for prerequisite outcome elicitation. Right. So that's the kind of medieval times. And now let's get to the return of the textbooks. Which is really modern history, and why the textbooks are returning, and what the kind of the work has been associated with the return of intelligent textbooks. So I think I would probably argue that it started around 2013. It has been contributed by a range of factors. In early modern history was mostly focusing on better ways of getting domain knowledge from a textbook. And a lot of different directions contributed to that. The progress of semantic web and the progress of ontologies. Lots of ontologies were created, very nice approaches for ontologies mapping were created. Information tree will get a great leaps with move to the language models, probabilistic models, and important data-driven ranking, kind of about the same time. So as a result, the quality of search become much better. But also NLP produce amazing results, and two of them to name are the topic models, the various type of topic modeling using LDA or, for example, and also key phrase extraction. So key phrase extraction can look at the text and extract meaningful key phrases. And key phrases are almost like concepts. They're not really concepts, but they're very close. So it's kind of rude approach to get knowledge in the text rather than the past approach of unigrams, like bag of words. It turns out that all of that could be really very nicely used to drive the new generation of textbook. And of course, the other important thing, the textbooks finally become electronic for real. So before that, we as developers had just to get our textbooks online ourselves. Every textbook was just created by the developers. But now there are plenty of electronic textbooks. There are platforms for electronic textbooks. So OpenStax, maintained by University of Texas, is a great example of a platform of open textbooks, high quality. It has everything you need, right? So we don't really need to hunt for them. We can just use what is around. And that fueled a lot of new directions of work. So there are just a few examples. Here's the example which is kind of guiding our current work as well. It's the PhD thesis of Sergei Sosnovsky. He tried to do something which we're really struggling to do even now, connect the world of smart content and the work of a textbook. So because to make a really nice textbooks, we do need smart content, which was not available. But now there is smart content, how we can connect it. So using ontology modeling, he was able to build a system which really can recommend smart content for the textbook pages and vice versa. For example, you try to solve a problem and you failed. And then by using this ontology linking, the system can recommend you the right page on the textbooks. In the past, we could do it, but we have to do this manually constructed concept models. Now we can do it semi-automatically. And then other type of works followed. NLP turns out to be a really great way to help more advanced concept linking. You can use topic models to provide richer knowledge about every page, and then you can connect them together. And so several different teams contributed to that. And in fact, we specifically wanted to be part of that return on textbook, and we get a large NSF project grant to work on this new generation of textbooks. And this is one of our works. We're trying to improve the content linking using topic models and key phrase extraction. So also, of course, a bunch of people who do information retrieval from IR domain try to use IR approaches for content linking, and it was including both approaches to link internal content, but also a lot of ideas to include link external content. Again, before that, it has been all done using topic-based models and manual indexing. Now you can do it using IR approaches. Here's a bunch of different works from University of Indiana and from Microsoft. So that, but the most important, I think, development was in fact the ability to extract the whole domain models. That was really more than just separate parts of connecting pages or finding key phrases. So the bunch of researchers have tried to do heavy lifting, look at the big bodies of text and try to build domain model, try to build the concept hierarchy automatically by using a combination of machine learning and natural language processing approaches. So a lot of work on that has been done in Penn State by the team of Lee Giles, but also at Carnegie Mellon University. And in addition to just extracting the network of concepts, there was a lot of efforts in trying to figuring out which of these concepts are prerequisite and which are outcomes, which is also very important for education. So some different types of data has been combined. The knowledge about from the textbooks and the knowledge from student work has been combined together to figuring out which page kind of need to come before which page. So that was really a very important contribution of work. So we try to do it ourselves. For example, we try to use machine learning to decide which concepts in the textbooks are outcomes, which prerequisites. So we built a range of different models based on our ideas of how a textbook should be constructed. For example, we assume that every concept generally presented as a whole in one place rather than in multiple places a little bit. We also believe that if it's a concept presented in a unit, it's very likely included as a part of the title. So a title gives you a hint what concepts are outcome, which are prerequisites. So we built a bunch of models and try to use it to predict what is a concept and what is the outcome, what is a prerequisite. And actually it's worked quite well. So we were able to train it on one set of textbooks and use it with a very good success on the other set of textbooks. So yes, machine learning, text processing, all of that, in fact, replicated the work of the domain experts. Not as great as domain experts, well enough to build the new generation of intelligent textbooks. And a number of different approaches has been, in fact, been constructed for that to benefit from that. So, for example, recommended pages. Okay, so now. The late modern history, the second period of the return of the textbooks. Now it's really focusing on not on the better domain modeling, but on better learning modeling, which were the two missing parts, if you remember. The main part of that was, of course, the large volume of learner data, but it came also with much better progress in doing learning modeling. In addition to classic BKT, a lot of different versions of BKT has been developed, like BKT extensions, IFM, PFA, deep knowledge tracing, which has been a richer ability to adapt to unusual situations like textbook modeling. Also, much better tools to analyze behavior, learning behavior has been created, like we start using matrix factorization, tensor factorization, sequence mining. A lot of that work has been originally produced in the recommender systems. We also get richer set of data collected. We can get now student interaction with questions, problems, videos. Some textbook has annotations, we can use it. And some people actually tried eye tracking. And another thing is now not just like online textbooks become mainstream, but online textbooks with smart content. Remember, smart content was important. If textbook is only text, personalization is great, but not really most helpful. Where it's really most helpful if you get the smart content, problems, work out examples where you can guide people. But now, smart content textbooks become a commonplace. There are plenty of them. If you look at Carnegie Mellon OLI, they get textbooks with smart content for multiple topics, including programming. Runestone is a new platform which generates multiple online textbooks with smart content. There is even open source tools like OpenDSA, which allow you to build your own textbook with smart content. So that's really helping to collect more data. And so people try to finally get to grips with better way of modeling. It's not kind of true to say, if you look at the page, you know the concepts on the page. But if you use data-driven approaches, you can try to build better student modeling from the textbook. And in fact, that's where most of our work has been focusing, because a bunch of other people do key phrase extraction or linking. But very few teams has been really focusing on how we can better learn about student knowledge by tracing their reading. So we did kind of a lot of work on the topic. But beyond us, there are a bunch of other teams who try to benefit from the new approaches to student modeling, including, for example, trying to figure out how we can use this wider bandwidth, annotations, eye tracking, to extend learning models. In our case, we only used the reading behavior, which we can kind of recognize as scanning or careful reading, and student answering in simple multiple choice question. But people try to look at more, the annotations, eye gaze. So that turns out to be a really valuable source on getting even better domain modeling. And now, in fact, there's a lot of work in this direction. It's not really kind of resulted in getting the solutions, but it probably will, because a lot of people now get to the data produced by humans by learning in textbook and trying to figure out how people learning, how they're learning differently, what are user patterns. So all of that might help us to do much richer adaptation than just like adaptation to the set of concepts. So we can take into account the ways of people learn, extracting for their partners. But it's still a promise, but there is a very large body of work on the topic, mostly presenting in the places like Educational Data Mining Conference. And in turn, this new generation allowed to do better personalization in textbooks. In the past, most of the approaches focusing on recommending people external content relevant to the page without taking into account learner knowledge. Recommending you Wikipedia articles connected to the page. Recommending you videos connected to the page. I already showed the links. It was kind of external linking, but there is no were no attempts in this kind of early modern period to figuring out, is it the good page for the learner, which is what adaptive books really can do. Now, when we get both better domain model and better student model, we in fact can recommend pages which are not only relevant to the current one, but in fact relevant to the user level of knowledge. So this is one of our recent projects. We're trying to recommend relevant Wikipedia pages, but not just based on where you are, but based on what you read in the past, what things you potentially missed, what things you read really carefully. So trying to combine advanced learning modeling in a textbook with the right recommendation. So that, again, well, we also, in the modern fashion, we get the explanation, and you can see that we get a lot of factors about the learner to contributing to the model, and we use it in the explanations. And that was been driven by a kind of combination of a traditional concept knowledge graph. That's the way it's called right now, and student model integrated with knowledge graph. Okay, well, finishing to leave time for questions. Contemporary history, that's what we're doing now, and that's a kind of the challenge to everyone who listens to me, which starts, I would say today, but since we're still not really at the very much end of 2021, and everything is slow because of COVID, let's start at 2020. So what I think are the challenges for the modern generation of return of the textbooks? I think the foundations are there. We now understand how to build domain models really nicely, automatically, and we get a lot of nice ways to use them. We have much better ways of bringing in student models. We have real textbooks, and we have a lot of textbooks with smart content. So now what the real change is bring it all together for the real impact, because it's still separate. Smart content textbooks are there, but they don't have personalization. And personalization ideas are there as well. There are lots of papers, but they're not used in mainstream textbook. I think the time is to kind of get the real impact, to start enhancing real textbooks with smart content. That's one of the challenges with personalization. And that is one of the challenges which we try to address in our series of workshops on intelligent textbooks. We brought together the teams who has been great experience in working in the textbooks, Rick Baranyuk and Andrew Lamb, and Sergey Sosnovsky and myself, who has been working a lot of personalization. But we all try to bridge the gap between building books and building personalization. And so that's what we're trying to do ourselves, and what I really encourage to do is try to build real textbooks which are smart, not just like write a paper, but try to build something real from extending some real textbooks. Try to build cross the border between text personalization and smart content personalization, which is not that easy to do. It's easy to recommend a piece of text, like a Wikipedia article, but it's not that easy to recommend the right piece of smart content, the problems to solve. But it is, if you remember my starting pages, that's where you get the most impact. So just a few examples of work which we're doing right now. So that is the work of Sergey Sosnovsky at Utrecht University. He's now really concerned with large-scale personalization for the textbooks. Take just a normal standard PDF textbook, any textbooks, and processes using all of the tools around textbook, like the glossary, index pages, key phrase extraction, and build rich models which can be used for making textbooks intelligent. And similar work is happening with OpenStax, with researchers there, and I hope that we'll get really interesting results going beyond the just research publication. And the real challenge, which is still kind of the future, is trying to connect smart content, make smart content textbook personalized. So this is kind of promotion of the workshop. So the third workshop on intelligent textbooks is coming at AI Education. And we are going to present our paper where we try to provide two-way connections between our typical smart content and the textbooks. So this is a way for us, for example, if you work with the smart content and you have troubles, bring you to the textbook and recommend the page from a textbook. And that's as vice versa. If you work on a textbook and you need something. So this is not recommending you a Wikipedia page to read or video to watch. It's recommending you a problem to solve or worked out example to work with. So that's it. I want to leave 10 minutes for questions. And of course, it comes with the saying that there's a lot of support for what we're doing, just like not my work, a lot of my students and collaborators. And it has been supported by a bunch of NSF grants. The most recent one specifically focusing on new generation of smart textbooks with my colleague, Professor Dachin here. We get also support from ADL to build our open social student modeling. So that's it. You're definitely welcome to learn more. Probably the easiest way for you to learn more is to come to Pittsburgh to visit us. We usually have visitors. This is a farewell to one of our visitors from Brazil. Or if you can't come, you still can read more if you look at our papers. Thank you very much for listening. Questions?
Thank you very much, Peter, for the wonderful walk through time. I think that was good for the ones that know more about it, because it reminded us of all the things that have happened and what is happening now. And I think it's also good for the next generation to understand where things are coming from, basically. Yes, Peter's workshop is on the 15th, and it starts at 2 o'clock CET time, I believe. Right, so we have already a hand up. WT, do you want to ask a question? Sorry, I can't tell your name from this. You can just talk.
Hello, yeah, I'm Tal. Can I show something?
Yeah.
Moment, I will share my screen.
Just want to see the face of people who are asking questions.
Yes, go on. Please ask the question.
Can you see something?
Yes.
Yes, yes, we see you.
Moment.
We see you.
Share. Yeah, I am Tao. Yeah, and I will share something. Yeah, I'm doing this job because I'm writing this textbook. But question is, the student just like that. This learning method, because how to set because they give them some working load, and try to be okay. I will show that. Oh no! Can you see something?
No. So maybe it's better to ask questions without showing the things, because as I see there are a number of hands rising. That will be delay if you try to connect and show something. Maybe just ask.
Because yes, we have this textbook, just a material translate. We can show the teacher how long did the student learn, and how long and which rank did the student in the group. Just like they can get A or B in the group, and they can compare it with the other. And so, but just to say that, just 20% people and students just like that. Because this semester I cannot finish, but I will continue to do the study. And I will make the report. Because
can I ask you to ask the question, because there are others. So what's your question?
Yeah, and how about the concentration? Because in these textbooks, so many these conceptual and connection, and they will just click one and just jump to the other website or something, then make more and more. Then this makes this student concentration is not so good, and they will get this heavier workload.
Great,
for the
excellent.
student.
So the point is there are so many ways to learn. That's exactly why you need not just textbooks, intelligent textbooks. Intelligent textbook can help you to get to the content you really need, not just to give you 20 different things, right? It tells you 2 things, but exactly the kind of things you need. It's a difference between looking at IMDb to get the right movie and looking at the movie recommender. You get 3 movies, but it's exactly the kind of movies you like to watch. So that's exactly why we need intelligent textbooks. One of the values. Of course, there's others.
Yeah, and can you consider some reward for these students, just for by in this textbook or in the platform that gives some reward?
Rewards help a lot, but also social comparison. The social navigation approaches help a lot. If people see how others learning, they do much more work without any reward. They just do it by themselves. But rewards never harm.
Okay.
Okay.
Okay. Thank you for your question.
Thank you very much. Yeah, thank you very much.
Can you stop sharing before leaving? Yeah. Claude, I see Claude Frasson, you had your hand up?
Yes. Okay. Well, I don't see Peter.
Oh, I'm here.
You are here. Okay.
We all see.
So it was you can hear me. It was a very interesting travel in the history of research works, and I appreciate it very much. Thank you, Peter. Since Vannevar Bush, this period where the user could read a text through motivation, through interest, through a focus in mind. It was the side from the user to textbook. Okay. Now with the tools, you present tools, and you cited one tool which is machine learning and also eye tracking. But we also can consider brain measure with EEG, with eye tracking and things like that. And what appears now, it's the other side. The textbook can read the mind of a human brain. For instance, it's possible to have a sequence of reading of concept and see the impact of this concept into the brain of a learner, and see if, for instance, workload occurs or frustration occurs, and this means that the concept is not understood. So the period in which we are entering since a few years is the other side. The textbook can read into the mind of a user, and it's a way to be sure that the concept is understood or misunderstood or without interest. So I think it's another way and evolution of intelligent textbook. Do you think?
Yeah, so thank you very much, Claude. That's the part of the research where you kind of pointed out, which are not yet used to fuel the future generation of textbooks, but it probably will. And then this mind reading is one other way of doing that. At least for now, it can tune us the student modeling approaches in textbooks, because if you only see the student turn pages and mouse over, it's not really enough. You can model the learner a little bit, but it's not precise. But with eye tracking and of course with brain reading, as you say, we can do even more. The challenges of this to make it mainstream. So we can tune our student modeling by looking at your eye tracking data, but your real textbook reading might happen without eye tracking, very likely. So we kind of need to make sure that eye tracking becomes a part of everyday's life. Your like webcam could be used to reasonably well track your reading, and with eye tracking you can do more data. Same thing with mind reading. We can use these brain interfaces to better understand how humans learn and tune our models. But it's still a while for us to, you start to do readings, you don your like a helmet, and it's now much more adaptive. Yeah, it's a good idea, but to make it a reality, but the technology is progressing. Yes, that's the cool direction.
It's possible to wear this light EEG, for instance, you know, and you could read in my mind.
Absolutely, that would be. We'd love to see people who do this kind of research, right? Especially that now technology becoming mainstream. Eye tracking used to be very expensive. You need to get an engineer who tune your head like for 10 minutes. Nowadays, it's like a small bar and it's reliable. You can do it with a webcam. So again, new technology empowers what we can do. Thank you very much for that point. I should insert it in my slides for the future.
Thank you, Peter.
Thank you, Claude. I think we're having all sorts of things all the time, right? Like your phone and whatever. So I think we're getting there with all these gadgets. So I think and smart watches and what have you. So I think it's fair to say that we are starting to wear technology all over, and we can probably measure all sorts of things with it. Exactly. I have a question myself. You proposed some time ago the Brusilovsky adaptation taxonomy, and I was wondering if that's still relevant nowadays in terms of adapting to and recommending the right problem to solve, so basically smart content, or if basically we need to see a new one.
I think, to be honest, Alexander, if you think about textbook specifically, the ontology, the taxonomy has to be extended because it has been created originally to describe general research in adaptive hypermedia. But if you look at the specific subdomain, like intelligent textbooks, you can try to dig deeper and get more different things. So it's a subdomain, and there a lot of new development. So I agree with you. Maybe it's time to do it. I need some help.
Okay, excellent. Yeah, sure. And also VR, XR, this is one of the directions we're moving into, so I like to put that top. Stefano Ceri, I see you had your hand up.
Stefano, great to see you.
Yes, I have. I just have an add-on to the excellent excursus from Vannevar Bush to today of Peter about the fact that I share the vision of Claude concerning the interest and the importance of motivation, emotions, and personality traits. The thing that you address when you talk about social. At the end of your talk, you talk about social, because this purely rational, old-fashioned, purely rational approach is very positivistic, but maybe has to go beyond, and maybe with a little effort that is only possible to do when you have a big reputation as you do. In order to consolidate this remark, I will tell you two anecdotes shortly, very shortly, that you can add to your history, just to reflect about. The first anecdote starts in 1947, when the father Jesuit Roberto Busa started to get money from IBM World Trade, from Thomas Watson, for about 50 years to build the biggest, let's say, old-fashioned computational linguistics work on the opera Summa of St. Thomas, namely, well, I was working on it for about 2 years, 170 tapes of Latin, medieval Latin, and the trick was not only to code and make books, but to make frequencies, concordances, and all kind of computer that are, let's say, a variant of hypertexts. Okay, and that story is interesting and important because it finished nicely, and it is the first person who started to use characters not only to represent, let's say, ASCII. Not only to, at the time it was ABCDIC, IBM, ABCDIC, not only to represent figures, numbers, but particularly to represent characters. The first person was Father Busa in 1947, just after Vannevar Bush. Great. And you find the whole story on the web. The other anecdote, and then I finish, that Mark Nanar, a previous colleague of mine from the hypertext area, told me about, that Tim Berners-Lee, just to encourage you to break these barriers, Tim Berners-Lee in 1990 to the second or third hypertext conference presented a paper on the World Wide Web, and the paper was refused.
Yep, nothing novel. I remember the case.
That is known. That is better now.
Yeah,
okay. So please go ahead with this study.
Thank you very much, Stefano. Right, great. Yes. Of course, I don't know about Father Buza, but if you can send me the link, I would really appreciate it. Include it in my history.
Yeah, no problem. You just do Roberto Buza.
Okay.
And Index Thomisticus is the name of the work. 50 years long. Index Thomisticus.
Oh yes, I got it. Thank you. Okay.
You'll find everything. Okay. Thank you, Peter.
Thank you, Stefano. Yeah, speaking of adding, I know you said about my authoring system, MOT, so MOT, my online teacher, that was actually implementing the whole Brusilovsky taxonomy. I think it was the only one. So,
yep. I agree. Right. Every early paper just tried to do one thing, but what the wise people who follow, they try to bring everything together. That was a very important part of the work.
I have another question. You said when these new directions of information retrieval from based on neural networks of full concept hierarchies, full ontologies, and you said, well, but actually there's still a disagreement between the machine extracted content and humans. But at the same time, if you take two experts in a domain, they also won't necessarily agree, and there is a disagreement, and it's a measurable entity of disagreement. So I was wondering how far is basically the automatic extraction from human disagreement?
Very nice question, Alexander. Thank you very much. That's actually the deal with the expert annotation, and it's also changing. In the past, experts need to create a lot of textbooks. They can't afford to get a lot of efforts to one textbook. So essentially, most of the early textbooks has been created by one domain expert. One domain expert extracted concepts. And you're kind of right. There's a lot of disagreement if you do it alone. And in fact, machine approaches are not that far from domain expert. Not as good, but still not as far. They can be considered to be weak domain expert. However, if now developing of this domain annotation is becoming a very rare case because we need them for training of the machine learning approaches, we can use very modern approaches for knowledge engineering and knowledge extraction. So a team of experts collaborating through a code book, right, can produce much more superior manual annotation. And you can afford it because you don't need to annotate 20,000 of textbook. You need to annotate 10. And this 10 will be used to train machine learning approaches. And that is still way better than a machine learning can do. But it depends what kind of presentation you need. If you need to give person one right page to read, one right problem to work, you may miss it right because your model is not precise. But if you use navigation support, then you tell, hey, here's a bunch of things, this is better than that, then you include the human mind as well. And human really help working together with AI, sometimes ignoring the wrong ideas from AI and contributing their own, as long as they get the right information. We're also working on that, but there's a very, very important concern. The new generation of textbook is different because while it's automatically constructed, these approaches are not as precise as we used to have in the past. So there are ways to leverage these approaches, to do recommendation, to do navigation support, has to be a bit more flexible. But that's the spirit of the time, right? We all the time would talk about that AI is not alone. AI need to collaborate with human. So I think the future intelligence books is a great example when in guiding people, we need to include human control, human prospect, right? When deciding what exactly is the right thing to do.
Yeah, thank you, because we also do some comparisons of for trend analysis, and we compare it against human differences of opinion, basically, because there's also there some space, basically. So I think I gave a tutorial on learning analytics before, and one of the things that we discussed was, is it the end of theory, and are we just data driven from now on and nothing else? Sort of we crunch the data and we produce everything from the data. And my hope is that there's a bottom up and a top down approach, and they will reach the middle. But at the moment, it's very fashionable to be bottom up, basically. It comes from the data and produce.
It's a very important, good point, but it's already happening. The data-driven, purely data-driven is kind of passé. Now it's a combination of data-driven and knowledge-driven. If you see what Google does, Google uses a lot of nowadays knowledge graphs, which are data produced by experts, integrating with data-driven approaches, even just like for search. And it was one of the mainstream. I was really surprised when I heard the talk 2 years ago by Andy Moore, who was at Carnegie Mellon for a while, now back to Google. It turns out that behind the stage, Google pays a lot of attention to these knowledge parts, and just data-driven. And in other ways, in the recommender system, this happens as well. There are approaches, we use knowledge graph using ontologies. So we're using explicit knowledge. So third generation of AI was kind of extracted knowledge, domain experts. Second generation was pure machine learning. But now all that comes together. And in fact, humans are coming there as well, because humans are also mediating potential issues of using AI. Happening, not quite much yet in education, but I'm sure it will, and we're all helping in this process.
Okay, thank you very much. Any other question? I don't know, Claude, if you still have your hand up?
No, not anymore.
I don't know, I see it as if it's up. Anybody else? Any final question? If not, let us all thank virtually Peter, uploading. And thank you very much for your talk. And yeah, if you want to hear more about intelligent textbooks, you can join him at the workshop next week, I suppose.
Thank you very much. It was a privilege to speak. I hope to stay more for the conference.
Excellent. See you. So I suppose this concludes. Yes. Okay, Kitty, down to you.
Thank you, Peter. Thank you very much.
It was an honor to have Peter with us tonight, and we will continue with the same force and gratitude tomorrow morning with Adina Florea at 10 o'clock Greek time. Alexandra, I think you are going to present her as well. This was your desire and wish. So I wish you all good night. Have a good rest, and let's see each other tomorrow morning, 10 o'clock Greek time. Bye-bye, and thank you. Bye-bye.